Okay guys, I want to show my progress with the crystal batteries and some successes, some failures. I would like to show the experiment with the board that I did in the past, like this one. I used to have the chemicals here on the board and the magnesium plates on the top of it, which is actually this board here. As you can see, I already dismantled it. Did not work very well. Here's the magnesium result. You get heated up. Well, I separate them, and one can clearly see that galvanic reaction. So my first formula did not work very well. But I also learned something interesting about it, which is there's always a first reaction, an oxidization over the metal, the magnesium, that has to be formed first, and then usually that stops the rest of the corrosion. Even though it loses a little power, it improves with time. But in a thin layer like this one, now it's too thin, so it doesn't work very well. So I decided to go the next step. By the way, the copper doesn't get eat up at all. It gets pretty dirty in certain spots where water is located or tape, but the copper doesn't get it up at all. So that's a good sign. Now I'm going to a different chemistry mixture, and according to Bedini's findings, just Epsom salts and the copper seems to be working. So I decided to melt a few Epsom salts in cups like this. Put Epsom salts, this guy here, and I put it here, and I melted the torch like this one here. And as it melts, then I take the magnesium and I put inside, just like these four you can see here. So I have, forgive me for that confusion, so I have 4 cells that I did just like that, no water anywhere. In the beginning it gives a very good voltage. Those 4 batteries are in series, a very good voltage and current, but eventually dies. So it's very difficult to get the right point of crystallization of melting the Epsom salts, putting there, you know, and melting and putting the magnesium on top of it. So, and if you make a mistake, you cook too much the magnesium salts, become this very, very hard rock. It's a rock, man. This is like, to break this, it's really difficult. It becomes this powder. So I decided to not melt it at all. I decided to use the Epsom salts in a crystalline form like this. The difficulty is how to make this thing glues on the surface of the copper, because if we put them like this, it doesn't stay there. So maybe Hudson is right about using sodium silicate. So I'm going to try to do one hand on a camera building of one cell. So what I did here, I took a cap. This is 1/2 inches copper cap. I put a little wire there. I'm going to take a toothpick. I don't know the name. You guys know. And actually I pour some sodium silicate here, and I'm going to make inside the cell the walls wet. Nothing special, just make the freaking thing whole wet. Right? You can already guess what I'm trying to do. So I do that. I take the excess off if there's any. And of course I go to my Epsom salts. And now, pouring the Epsom salts, I do have it glued to the walls. And that's what I want. I want that crystalline format. Okay? So the same thing I'm going to do to a magnesium, piece of magnesium that I cut it. And I made a little hole, I put a little screw there. So I'm going to do exactly the same thing. I'm going to dip in my solution silicate, take the excess off, go to my Epsom salts, and it's pretty dirty, as you can see, pretty impregnated. And one thing that I do, I take a little piece of paper like this one, dirty a little bit too, sorry about that. So why I'm putting a piece of paper? Because I don't want the magnesium to touch the copper in fashion away at all. And I can impregnate this little piece of paper on the Epsom salts. like this, put around, and grab this baby here and put it inside my cell. A lot of pressure because the crystals very tough, but this guarantees me there will be no short-circuiting of the copper and the magnesium. So I'm trying to press this by hand and clean the excess off so I can show something interesting. So absolutely, this is not short-circuiting the magnesium and copper. So let's put it in a meter. Okay, it's right here. I'm opening this space. I have my meter over there. I'm going to connect negative on the top. I'm going to connect the positive to the bottom with the clip. So what I'm doing here is this positive and negative, or vice versa, and I'm connecting to my meter on the wall. And it's supposed to show. Oh, sorry, wrong bit. I'm connected to the wrong cell. This is the cell I want to connect, the one I just made. So positive, negative. Okay, very good. There's a brand new cell there, connected, and the voltage is 1.4. That's pretty good. But that's not all. Now I'm going to short circuit this battery using this meter here. So this is an microamps, not milliamps, microamps, 5 digits. So I'm going to connect the positive to the positive and the negative, short circuit the battery. And I did that, and voila, almost 3.6 milliamps. And the voltage drops to 0.3. This is the best cell whatsoever. Short-circuited, full load, that high milliamperage. Usually I get like 100 microamps. This is, now here's the thing, you see it is going down. But actually, as I let it rest, just like that, this goes up, goes to almost 4 milliamps. And the voltage here goes to 0.3. So no heating, no water, just a little bit of silica to glue the crystals, let it dry, and I leave the silica to dry. And when the silica dries inside and becomes a rock, that current increases. I think it started to increase now. See, it's going up. And voltage, I think, is also going up. And it's shorted. So it's under load. This is phenomenal. I mean, you can't beat that. There's no water. Simple construction with one hand. All you need is copper, magnesium, Epsom salts, a little bit of silica. Simple as that. And that baby will go to almost 5 milliamps. Just one tiny little cell. This is a winner. There's absolutely no way this is not going to be a winner. Now, of course, I'm going to let it run for days, see what's going to happen, like everything else that I do. This one I'm doing Bedini style. Great score, Mr. Bedini. Thank you very much, man. Great work for us, for the world, actually. And so this one is melted Epsom inside the cup. So I put Epsom salts here. I melted using the torch. Right? Of course, not touch my fingers like that. And then when it gets the right point, when it's melted, very careful, I stick the magnesium inside like that. So those 4 cells are that. And it's hard like a rock. And now in the beginning it starts with very good current and voltage, but then drops tremendously with time. So I don't know. This one, it keeps going up as it is shorted. And I think it's going up because the silica is drying. So the crystalline formation is causing what we expect. So I'm going to make a few of those. I have about 10 I'm going to make now. I'm going to put them in series and light up some LEDs. Okay, guys.